Friends, and welcome back. In this lecture, we're going to do something a little bit different. We're going to take some time to pause and import a bunch of different sound effects and different audio music assets that we can use throughout the remainder of this course. However, importing audio assets that we can use is always a little bit tricky. I'm going to go ahead and use a bunch of open source or assets that I've accumulated on my own that I can use for educational purposes, but there's a few that I can't redistribute back to you directly. Now, I realize gathering assets can always be a little bit of a pain in the butt. So we've gone ahead and found a bunch of CC0 open source licensed sounds that you can go ahead and use in this project. You can find that folder in the resources tab of this section, and you can go ahead and download that zipped folder. So you have a few different options. You can either use that folder, go ahead and grab a bunch of your sounds on your own right now that sound like the sounds that you're going to need. I've also left a few links in the resources tab that you can find to a bunch of different URLs on great places to find free sounds. Or you can gather them one at a time throughout the remainder of this course as needed. All of those options are totally fine, but I'm going to give you a little bit of a preview of the sounds that I'm using specifically, but some of them don't actually match the exact sound that you'll find in the folder, since some of them might not necessarily be CC0 before I put this course together. But I can't stress enough, it really doesn't matter much, just find some audio files that sound good to you. Let's start with music because I think that's a little bit easier. All I've done is create an audio folder in my assets directory, and inside here I have two different folders for both music and SFX. Inside of my musics folder, I have a disco party music and some fight music. I'm just going to go ahead and click autoplay so we can see what all of these sound like. So the disco party, hopefully you can hear it okay, is something that's just kind of a goofy little jingle that we can play when our disco ball is hit by the player. The fight music is just something that we can play as some default music in the background when we're just playing the game. So mine sounds something like this. Yours can sound whatever you'd like. Now moving into the SFX folder, we'll kind of go through one at a time just so you have a little bit of reference. And this is a bit tricky as well because each individual sound effect is going to vary in the amount of volume that is coming out by default. Now we're going to create our audio in a way that is easily customizable and solvable, but for now, let's try to go through each individual sound to see what it sounds like. You're going to need some kind of default grenade beep. A little bit later on in the polish section, we'll implement a grenade and we'll beep it a few times before it explodes. We'll also have a generic explosion. I've called mine grenade explosion that we'll use for when the grenade explodes. We'll have a grenade shoot, which is going to be different than our rifle shoot, kind of like a grenade launcher sort of sound. We'll have a jetpack later on in the polish section. We'll implement a little bit of a jetpack. This is really quiet, so we're going to have to ramp this volume up quite a bit. You probably barely heard it. And a generic sort of Super Mario jump sort of sound. You'll also want some sort of mega kill sound. Now, I actually made this sound on my own, but all you need is some sort of sound effect that if you kill a few different enemies within quick, short succession, it plays a mega kill sort of sound. Yeah, it might just be a sort of bonus sort of jingle. It really doesn't matter what your sound effect is, but mine sounds like this. Mega kill. You'll also want some sort of player hit effect that when your player takes damage. And then a generic shoot sound for when we're just firing our normal gun. Now, one thing that's cool is we're going to implement this in a way that we can vary pitch through things like shoot. So if we're firing a machine gun, each individual shot is going to vary the pitch quite a bit. And then I have two different splatters because we're also going to implement a way that we can randomize which individual sound plays when, say, something like a slime dies. So I have two different splatter sounds. Pretty quiet, but all it really is almost like a gushy fruit sort of smash. All right, well done on this lecture. When you're ready to move forward and start implementing an audio manager class, I think you'll really enjoy it. I'll see you on the next lecture. Let's have a conversation about how we're going to hold all of this audio data. And the way that we're going to do that is with introducing scriptable objects. Let's dive in. So in our assets and in our scripts folder, let's go ahead and create a new folder that we can call audio, and we'll put all of our audio related logic inside here. Inside of our audio folder, let's create our first scriptable object class, and we do that by creating a new C# script. Now we can call it whatever we'd like, but I'm going to go ahead and call it my sound SO. SO for scriptable object. And let's open that up in VS Code. Now, just as a reminder, a scriptable object is basically just a way to hold data, but it doesn't need to be instantiated in our scene like a typical mono-behavior class would. There's a few different things and different implementations that we can do with scriptable objects, but for our use case here, we basically just want it as a way to hold data and make it easily modifiable in the inspector. So we're essentially just creating a sound SO for each individual audio that we can then implement a bunch of different properties. So let's rig that up and it'll make a bit more sense. Instead of inheriting from mono behavior, we want to inherit from scriptable object. Right above that class, we can go ahead and open, close some brackets and type create asset menu with an open and close parentheses, and that'll allow us to create this sound SO directly inside of Unity. So let's take it one step at a time just to make sure that we're all on the same page and you can see what this looks like back in Unity. For now, let's go ahead and create a public enum that we can call audio types. Inside here, all I'd like to do is create one for my SFX, so SFX, comma, not a semicolon, and music. Below that, let's expose that in the inspector. The way that we do that is we create a public audio types, calling it audio type without an S at the end for single, and then we'll capitalize it with a capital A at the beginning, since typically and generally speaking, all of our variables inside of our scriptable objects are public because we want to be able to read and get this data from other locations. And we're probably going to have 7 or 8 towards the end, but for now, let's just create one more. Let's have a public audio clip. And we'll just call that our clip with a capital C. Let's go see what that looks like back in Unity. Let's head back into our assets folder. Back in audio, let's create a new folder that we can call sounds SO, because we're going to throw in a bunch of our scriptable objects in here. But for now, let's just create one. So now we can actually right click, create, and we've gone ahead and at the very top, you can actually see we've created this sound SO option. We can go ahead and click that and create our scriptable object. Let's just set up shoot as an example. I think that's a good place to start. And inside here, we now have this drop down for choosing between SFX or music. It is indeed SFX. And then we'll just go ahead and select our shoot clip. Very nice. Now we're separating these audio types between SFX and music because a little bit later on we're going to introduce an audio mixer and making sure that those two are handled separately. So for now, let's just go ahead and select FX. Let's hop back into our sound SO and fulfill a few more properties. Now I typically don't like to just list a bunch of different variables before we use them, but I think in the context of what we're doing here in our sound scriptable object, it makes sense. So what else would be helpful when we think about audio? Well, let's create a public bool to see if we'd like to loop it. I think by default we can set it to false. Let's also create another public bool called randomize pitch, and we'll set that to false as well. For example, we might want things like our bullets to randomize pitch every single time we shoot it. So if we have randomized pitch set to true, we'll also set up some additional logic to randomize that pitch by a degree that we'd like to set. So we'll create a public float called random pitch range modifier. We'll set that to something to itty bitty teensy small like 0.1f. But one thing that's extremely helpful in the inspector is we can create a range attribute and then just go ahead and do that with open close brackets, type range, and then open close parentheses, and we can type something like 0f to 1f. That way when we get back to the inspector, we have a nice little slider going back in between 0 and 1, and we want to make sure our game designers or just ourselves directly, we don't go outside of that range. So let's create a couple more. We'd like a public float for volume, and by default we'll just set that to 1 because that's the way that it's played through audio. And public float for pitch, and we'll also set that to 1 as well. That'll just be the default sound that the audio was imported at. Now I'm going to create a couple more range attributes for both my volume and my pitch, except we can set my volume to something like, I don't know, 0 to 2, and then maybe our pitch something like 0 to 3, even though we'll probably never go that high. Let's also make sure our pitch is set to something like 0.1 and maybe our volume is set to something like 0.1. just so we have a little bit of a minimum to make sure that the sound is always coming through properly. Nice, I think that's all we need, but to me this is just super exciting because now we actually have the ability to modify each individual sound as needed through this scriptable object directly instead of cluttering up and messing up our code everywhere. Let's head back into Unity and see what it looks like. Heading back into our assets folder, audio and sounds as so, now when we click shoot, we have all of these other things that we can modify as needed. I don't want my shoot to loop, I do want it to randomize our pitch, and then we'll leave these other three values like this for the moment. We can modify them a little bit later on if we should need. But let's just do one more just to kind of drive the point home before we move on. So let's create another sound SO, and let's just create our jump. We'll go ahead and make sure that's set to SFX. We'll properly put in our jump audio. We don't want it to loop. I don't think we really want to randomize the pitch. And then we can go ahead and leave the other three as is for now. And that's the real power behind our scriptable objects here, is you could have dozens or even hundreds of different scriptable objects. And even with working with something like a sound designer, the sound designer can directly come in, modify the scriptable object however they need, pass it along to the programmer and say, however you'd like to implement these sounds, go for it. All right, let's keep moving forward and bring this whole thing together. I think we're going to need to see a little bit of a bigger picture before the power of this all comes in. Let's move forward and start taking some of the first steps towards setting up our audio manager class to actually get some of these sounds firing. When you're ready to move on, I'll see you on the next lecture. In this lecture, let's play some of our first sounds setting up our audio manager class. So let's go ahead and get that rigged up, and let's go ahead and plop it in this manager's game object. So scripts, audio, right-click, create, and let's create a new C# script called audio manager. I'm going to go ahead and create that, so audio manager in our hierarchy, and we'll attach our audio manager class and open it up. Now this audio manager class is going to be pretty big and pretty fancy schmancy, but let's make sure we're just taking it one step at a time, and I think the most logical place to start is let's just get a sound playing, period. So let's set that up. And we'll use our on shoot as an example. So let's create a serialized field. We'll call it private sound SO, and for now we'll just call it gun shoot. And a beautiful thing about the observer pattern is we have everything we need to just plug in directly to our gun shoot event. So let's go ahead and subscribe to those events in our gun class appropriately. So on enable, on disable, and all we need to do is go into our gun, on shoot, and subscribe to something. So let's go ahead and subscribe something to it. Let's create a private void, and I'm going to call it gun with an uppercase G underscore on shoot, and then we'll follow that naming convention moving forward for all of our audio sounds as needed. So let's go ahead and subscribe gun on shoot to our gun on shoot action. So gun on shoot, and we'll just go ahead and duplicate it and make sure we're unsubscribing to it as well. But what do we actually want to do? Well, we want to create some sort of generic play action that we can use for all of our sounds. For now, let's just call it play sound and get something playing back in Unity. So let's create a private void play sound, and we'll pass through our scriptable object. So sound SO with a lowercase s, and then what we're going to do is every single time we play a sound, at least for now, we're just going to instantiate a new audio source and then just play it directly through that. So let's create a new game object, and we'll just call it sound object. And now let's just create a new game object, and we'll call it temp audio source. And let's attach an audio source to it. So audio source, we'll call it audio source. And then onto our game object, let's just add a component, audio source. And what clip do we want to play? We want to go into our audio source, dot clip, and then just change it to the sound SO dot clip with an uppercase C dot clip. And then we can play that directly through the audio source. How do we do that? We just say audio source dot play with a capital P. Now, when we fire our gun on shoot event, all we need to do is play sound and then pass through our gun shoot scriptable object. Nice. And I think with that, we ought to be set to go. Let's head back into Unity and see how that sounds. On our audio manager, let's go ahead and select our shoot sound SO. Let's hit play and see if it works. Nice, we are in business. Every single time we shoot, we have a nice little sound effect firing for the very first time. And just like that, I believe our game really is coming to life. And that'll bring us into this lecture's challenge. Following the exact same pattern, get our jump audio clip playing every single time our player jumps. Go ahead and pause the video, take a few moments to give that an honest effort, and I'll see you back here shortly. Alright, welcome back. Let's hop back into our audio manager, and all we need to do is create another serialized field. We'll just call it jump for now. And we want to subscribe something to our player controller. And let's just double check we have that set up correctly. So player controller public static on jump. Yep, that'll do. Let's go ahead and create a private void player controller underscore on jump method. All we want to do is play sound, and we want to pass through our jump sound scriptable object. Let's go ahead and subscribe to it. So player controller dot on jump, and then we'll subscribe to that. So let's see, what did we just do? Player controller on jump. There we go. Duplicate it, shift it down, and unsubscribe appropriately. And with that, we're all set to go. Let's go see how both of those sound back in Unity. On our audio manager class, let's just make sure we assign our jump sound SO, click play, blow up our game view, and see how everything sounds. Alright, every single time we jump, yep, sounds good to me. Now you can see every single time we shoot, I think that sounds about right. Every time we jump, it's a little bit loud for my taste. So let's move forward to the next lecture and continue forward, adjusting our sound audio manager class appropriately. When you're ready to move forward, I'll see you on the next one. In this lecture, let's manage all of our fun, unique sound scriptable object values as we manage things like pitch, volume, and if they're being looped directly into our audio manager. Let's head back into our audio manager class and set it up so that we can manage those things appropriately. Above our private void play sound, let's create another private method called private void sound to play. And this is actually the method that I want to pass through my sound scriptable object. So we're not actually going to pass through that sound scriptable object directly through our play sound. In our sound to play, we can modify all of those different values and then pass that through our play sound to attach to our audio source. So for example, the clip, all we need to do is actually just pass through the audio clip, and we can just call it clip for short. And then we can just assign our audio source clip to that clip that we pass through as a parameter. But we need to make sure we're actually playing this sound in sound to play. So play sound, and then we'll pass through those values. But let's actually tackle it a little bit more above just to kind of clean up the way that syntactically this looks. So I'm going to take my audio clip. I'm going to call it clip, and then we're going to go into my sound SO, except I do want this capitalized. So sound SO with a capital S, capital O, that looks nice. And then we'll go into my sound SO dot clip. And we want to do the same for things like pitch, volume, and loop. So let's actually just do that. So we have our float pitch. We want to go into our sound SO dot pitch. We have another float for volume. And then we want to go into our sound SO dot volume. And then one more, except this is a bool for if we're looping or not. We'll call it bool loop, and then we'll just go into our sound SO dot loop. Now, the reason we're doing it like this is for things like pitch or maybe even our volume, we want to actually modify that sometimes. So in our play sound, we want to pass through our clip, our pitch, our volume, and our loop. So let's set that up in our play sound as well. So we have a float for pitch, float for volume, and a bool for if we're looping or not. Now we can actually just start and assign those values to our audio source. So audio source dot pitch equals our pitch that we passed through. Our audio source dot volume is equal to the volume that we passed through, and you guessed it, our audio source dot loop value is just equal to our loop bool. A good example of why we're setting it up like this is our volume. Let's say on our audio manager class, just here at the very top, we wanted to have a master volume value that we could just edit in the inspector. So let's create a serialized field as a float, and we'll call it master volume, and we'll set that to 1 by default. This way, when we get back into Unity, especially while recording, I can manage the master volume and slide it back and forth and edit all of my sounds appropriately directly in the inspector. So for example, if we want to modify our volume, we just want to go into our volume and then just times it by our master volume. That way we can pass through this volume directly into our sound to play. Well, what about our pitch? Sometimes we're randomizing the pitch, right? So right here, we can actually go if sound SO dot randomized pitch, and if it is, we want to modify it. So let's create a float called random pitch modifier. In here, let's set it to be a random dot range, and then let's make sure we take somewhere in between the negative value to the positive value and add or subtract to it. So negative sound SO dot random pitch modifier that we set in that scriptable object to the positive value. So I'll just copy paste that here. Once we have that random pitch modifier, right below that, we can set our pitch equal to the default sound pitch that we pass through, plus our random pitch modifier, since that might be a negative or a positive value. Nice, I think we're looking good so far. Let's just make sure we fix that we're not passing through play sound. We're going to sound to play and then pass through our scriptable object as needed. Nice, it looks like I have a compilation error somewhere. Ooh, barely saw that. All right, we just need to put a semicolon and we're good to go. Let's head back into Unity and play with some of those values. So all I need to do to change the volume or the pitch of something specifically, I can just go directly into that sounds specific scriptable object. So for example, let's change the volume on our jump. I'm going to change it down pretty significantly just to make sure we can hear the difference. And let's change it down to something like half. Click play and we'll see what that sounds like. Nice. Nice. I think something like 0.5 is appropriate. Now, a little bit of an important note, because these are scriptable objects, you can actually change them as needed. So for example, if I go all the way down to 0.46, unclick play, these will actually not reset back to the values of when before you clicked play directly in the engine. Let's try out randomizing our pitch. So for example, if I hit play, hit jump to see what that sounds like, and then shift the pitch to something way, way down to see if it works. Yeah, we're going to get some fun, goofy little sound effects. But if you unclick play, these will actually keep and remain the value that you have it set to. So for something like shoot, I think we're randomizing our pitch. I'm not sure if we actually heard that yet. I wasn't really paying attention to it. But every single time we fire shoot, nice. You can barely hear it. I think that adds some nice variety to each time we shoot our bullet. It's randomizing the pitch appropriately. So you could actually ramp it up to make sure it's working appropriately at something really drastic. Yeah, okay. Woo, probably a bit too much. I'm going to set it to something like 0.13. It's probably good. I'm not going to stress about it too much. Oh, I did actually just realize something that's going on that I forgot to chat about. So specifically on our scriptable objects, when we have these values, pretty annoying. You actually can't just say change this to 0.1. And then if you were to click away and go back to it, it's actually going to remain the previous value. So you actually do have to use these sliders to get back to where you're looking for. And the reason for that, I'm not sure if it's exactly a Unity engine bug, but I think it has to actually do with the way that scriptable objects read and edit their value as opposed to, say, something like a class. So we just want to get pretty close to our random pitch modifier, something around 0.1. And then now, actually, if we toggle away from it and toggle back to it, those values are going to save appropriately. Kind of annoying, but the way that scriptable objects work, at least in Unity 2023, hopefully that gets edited sometime in the future. And then on jump, we just want to make sure our pitch is set to close to 1. All right, now if you click play, you can see a bit of an issue. If we just go ahead and create a bunch of different audio sources in our hierarchy, well, they're kind of cluttering up our hierarchy, and that's definitely something that's not needed. So let's head back into our Audio Manager class and adjust one more thing before we move on. In our play sound, we can just check. If it's not looping, we just want to destroy our sound object. So I'm just going to do it all in one line, and we can go destroy sound object. And then destroy allows us to put in an overload for the amount of time we want to wait before we destroy it. Well, perfect. All we want to do is go into our clip.length, and that'll give us a float value on the amount of time that we want to wait before our sound object is destroyed. Now, you might have noticed this might not be the most performant way to necessarily do this. You could potentially object pool your audio sources or something along those lines as well. It's a bit out of the scope of this course for how much I want to dive into it, but it's important to note. Nice, let's head back into Unity and make sure that works before we move on. And now you can see when you play a bunch of different sounds. If I scroll down by hierarchy, you can see these temp audio sources being destroyed appropriately. Alright, with that set up, we are making some great headway and progress through our audio manager system. And when you're ready to move on, I'll see you on the next one. This lecture, let's make it so our sounds not only play their pitch, volume, but we're also randomizing sounds if we have more than one, in our case, our splatter effect. To do that, we're going to need to create one more scriptable object class. So back in our assets folder, scripts, and let's see if we can find our audio folder, and let's create one more C# script. And let's call this one our sounds collection SO, because we're also making this a scriptable object. Before we open that up directly, let's actually head back into our audio manager to talk about what we're trying to achieve. So in our audio manager class, we have these serialized fields full of our sound scriptable objects. Well, in our case, we have 11, and that's already going to actually be quite messy. So I'd like to set up some sort of intermediate scriptable object to hold all of our other scriptable objects. We can do that in a way that each individual sound holds an array of sound scriptable objects, and then we can randomize which one to play if there's more than one. So in our case, let's go ahead and open that up. We just created the sounds collection SO. Just like we did before, let's not inherit from mono behavior. Let's inherit from scriptable object. And right above here, let's just create an asset menu. And one thing I love about scriptable objects is we can have a scriptable object that just holds a bunch of other scriptable objects. So in our case, let's set up the ones that we have set up so far. We have a public sound SO, and we can create that as an array and call it our gun shoot. So even though we just have one, we can set up multiple. In the case of our jump, we also just have one, so let's set up one more. So sounds SO also as an array. We're just going to set them all up as an array because that's how the logic is going to work in our audio manager. We'll call this one jump. And now this is going to be the first one that we're going to have two, which in my specific case, I have two different splatter effects when our enemy and our player will eventually die. Let's create that as well. So sounds array, and then I'm just going to call it splat. And then we can head back into our audio manager class. And now we no longer need these two at all. So I'm just going to go ahead and delete those entirely. And then I'm going to create a single serialized field, which is going to be a private sounds collection SO. And then we can just call that our sounds collection SO. Now we can just scroll down and fix the compilation errors we're getting down here. Instead of just playing the gun, shoot, and the jump directly, we want to go into our sounds collection and then fire our gun, shoot. Down here on jump, we want to go into our sounds collection and fire on jump. Nice, and before we rig up one for our splat, let's go fix up the logic that we're getting up top. So we need some additional logic to make sure we're randomizing which one to play. Let's create one more private method to do so. Let's call it private void play random sound. And then this time, we're actually going to take in sounds SO as an array. And we'll just call that sounds. Inside here, let's just check and make sure that sounds is not equal to null. And sounds.length is just greater than 0 to make sure we're avoiding any null reference exceptions. Now let's create a new sound SO by going in and choosing a random one from this array. So how do we do that? We just create a sound SO that we can call sound SO. To set that equal to be sounds, and then we need a random index. So random.range 0 to sounds.length. That way now we can just call sounds to play and pass through that sound SO, and we don't need to refactor anything here. All we need to do is instead of calling sounds to play directly into these methods below, we just want to call play random sound. So I'll go ahead and replace both of those and everything should work as intended. Let's head back into Unity and see what that looks like. So now on our Audio Manager class, we need to create a sounds collection SO. We can go ahead and do that in our audio folder. And then right here, without creating a new folder, I'm going to go create sounds collection SO. And let's just call that our sounds collection SO. I only ever intend to have one. However, this might actually scale in a way so that if you'd like to have a couple different sound collections, you could do so. In our case, we are going to open this up and we can now see we can put in as many sound SOs as we'd like into each individual sound. So for our gun, let's go ahead and we just have our shoot. For jump, we just have our shoot. But in the case of our splat, we have a couple. So let's go create those. Inside of our audio sounds SO folder, let's go ahead and create a couple more sound scriptable objects for, let's call it splatter 1 and splatter 2. So I'll go ahead and rename that and create both at the same time. Inside splatter 1, let's set that equal to be splatter 1. Randomizing pitch sounds good. Volume sounds fine. I think we can make it a little bit louder. We'll leave it at that for now. We'll randomize the pitch at whatever we'd like. And then splatter 2, we'll go ahead and set that to splatter 2. Now for me, my splatter 2 is a bit quiet. So I am actually going to ramp up my volume just a bit on splatter 2. We can randomize the pitch a tad. Don't want to randomize it a ton on this one. And now we can head back in to our sounds collection SO and create 2 different sounds SO in our splat array. So splatter 1 and splatter 2. Nice, we haven't actually rigged up splatter 1 and splatter 2 by playing through anything in our audio manager. Let's go do that in a second. But just to kind of keep me sane, let's make sure everything is working as intended so far. Nope. I knew I was forgetting something. That's why I checked. Let's go ahead and see what our null reference is. Okay, we do still need to actually just drag in our sounds collection SO. So sounds collection SO, let's make sure that's all rigged up correctly. If we click this, we have our shoot. We have our jump, which is somehow also set to shoot. I probably misclicked. Let's make sure we set that to jump. And then splatter 1, splatter 2. All right, let's try that one more time. We're shooting. I like that. And let's see if we're getting a jump. Nice, very nice. And we don't have a splat yet. Let's go set that up in our audio manager. So opening up our audio manager one more time, let's go ahead and create this. So at the very bottom, let's create a private void health underscore. I think we called it on death. So let's actually make sure to see what that looks like. So if we open up our health class, we have a public static action health on death. So we do need to rig this one up slightly different. For the sake of pattern recognition, I'm going to go ahead and just plug this in directly to my audio manager class. There's definitely some arguments to just subscribe to a different event in our audio manager directly on health, but I kind of want to keep my pattern the same in our audio manager. So the way we're going to do that is we do need to pass through that health component. So we're not going to use it, but we do want to play random sound, and then we just want to go into our sounds collection SO dot splat. And that is holding both of our splatters. So up here, we just want to subscribe to it. So health dot on death plus equal health on death. Very nice. And let's unsubscribe to it as well. So minus. And with that, I think we're all set to go. Let's see. Let's give it a nice once over, make sure we're not getting any compilation errors, and let's go see if we're properly randomizing this sound when our enemies die. All right, let's listen closely. So let's hit play. All right, I think I heard the first one, I believe. I think that was the first one as well. And there was the second one. Actually, I think it's the other way around. I think the first 2 times it played the second one and the last time it played the first one. But I think we're all set to go. We are correctly randomizing the way that we'd like to play our splatter sound effects. We're randomizing the pitch, we're jumping, and everything is set to go. And I think you now see we can set up everything else we want as needed. Well done on this lecture. When you're ready to move forward, I'll see you on the next one. This lecture, let's set up an audio mixer so that our audio effects like sound effects and music can play through separate audio mixer groups. To do that, let's head into our Assets folder, Audio, and then directly in here, I'm going to right-click and create an audio mixer. So right here in the middle, Audio Mixer, and we can just call that Audio Mixer since we're only going to have one. If we double-click that, I think we should get it to open up. I believe if you even have this tab closed, I think you should be able to double-click it. Yep, open it up. And then I'm just going to drag it over here in my top left so we can look at it. Once we get our audio sources outputting this specific audio mixer group, we can even control things like the master volume and then more importantly, break this master audio mixer off into a couple different groups. And the way that we can do that is we can go into groups, left click this master because we'd like to branch off of it, and then click this little plus icon. I'm going to go ahead and call this one music. Let's make sure we click master once again, click plus once again, and then we'll call this second one SFX to match the way that we have it set up in our scriptable objects. This way, when we output that sound in our audio manager, we can modify these separately as needed. So even though we're not going to go too far down the audio mixer path, you can do things like expose these settings to get read and write values from it, so you can modify things like your volume inside of a hypothetical settings option. For now, let's head back into our audio manager and actually work on some of the programming inside. Up here, let's create a couple more serialized fields for our audio mixer groups. So we can create a serialized field. We'll call it private audio mixer group. I think when we do that, yep, it'll go ahead and import the using engine.audio namespace for us. And I'll call the first one the SFX mixer group, and then we'll need one more for the music, so I'll go ahead and duplicate that line, and then we'll call this one the music mixer group. And I'm also just noticing up top, I think it makes sense to have a range of 0 to 1 for our master volume, so let's do that as well. So a range 0 F to 1F, just to make sure it's always in between 0 to 1. And you know what? It probably makes sense to even change that to something like 0 to 2. We'll leave it at that for now. It's not too important. We'll leave it at that for now. So what would we like to do? In our sound to play, we need to make sure that we're also passing that audio mixer group into our play sound. So we'll go ahead and pass that through as the last parameter. So audio mixer group, we'll call that audio mixer group. And in sound to play, let's also make sure we set that correctly. So audio mixer group, we'll call it audio mixer group once again with the lowercase a. However, this time we're not actually going to initialize it as anything by default because we want to go into our sound scriptable object and actually check to see if we're set to a SFX value or a music value. So right here, let's actually do this with a little switch statement. So we can type switch, head down to switch here, and then we want to sort by our sound SO audio type is the enum that we plugged in our scriptable object. So here we can create our first case. And we'll just go ahead and let IntelliSense auto-complete it for us. So soundso.audiotypes.sfx. If it is, we want our audio mixer group to be equal to the SFX mixer group that we set up top. We'll go ahead and break it and then make sure our next case is the exact opposite. So we'll check if our audio types is music. And if it is, we'll set our audio mixer type to be equal to our music mixer group. We'll break that as well, and then default is basically a fancy way of saying else if. So if none of those are fulfilled, we'll just set audio mixer group equal to null, and we'll break that as well. Even though that we know in our case we only ever have 2, so this should never necessarily be fulfilled, but it's a nice way to make sure we're not getting any sort of null reference exceptions. Last but not least, in our play sound method, we'll pass through our audio mixer group that we just set. Nice. Scrolling down into play sound before we play it, let's set our audio source dot output audio mixer group equal to our audio mixer group that we passed through as a parameter. That way each individual audio source will be separately either in the music audio mixer group or the SFX mixer group. Now we don't really have a great way to test it yet because we haven't set up our music, so let's do that next. Right below to check if we're looping, let's just go ahead and check if our audio mixer group is equal to the music mixer group. Well, then we want to do something specific to make sure that we can only play one audio source at a time if it's music. Hey, Stephen here, about 5 minutes from the future. You can see a pretty big typo here where I'm trying to compare audio mixer group to the music mixer group, but I'm using a single equal sign. That should most definitely be a double equal sign for a comparison. We're not trying to set the value. I'll get that cleaned up in a few minutes. So let's cache that specific audio source reference up top. We'll call it private audio source, and we'll name this one current music to make sure there's only ever one at a time. Scrolling back down, we can copy that, and we can check that if this is the case and that the audio mixer group is equal to the music mixer group, then we'll also just check that if current music is not null, then let's just go ahead and stop that music since it's an audio source. And then regardless, let's make sure our current music is set to the audio source that we're playing if all of these things are fulfilled. Now, you probably could have done this as a double and statement or something along those lines, but I think this works just fine as well. Let's go create our fight music and disco ball music methods down below. So let's create one for private void, and we're just going to call this one fight music instead of actually going into a specific class naming convention. In here, we just want to play random sound, and I don't think we've created this as a scriptable object yet, so let's go ahead and do that in our sounds collection SO. We can create a header just for organization, so header, and then we'll call this one the SFX header. We'll duplicate this, scroll it up a tad, and then we'll call this one the music header, just for some organization in our inspector. Let's go ahead and create a public sound SO as an array for our fight music, and then we'll duplicate that, and let's also do one for our disco ball music. Now, I might be getting some of my naming conventions a little bit off. I can't remember exactly what the audio sources are called. It might be good practice to double check, but let's go ahead and make sure everything is rigged up first. Before we go and assign these values in the inspector, let's go ahead and finish off our code. So fight music, we can go into sound collections SO dot fight music. For our disco ball music, we need to be a little bit more specific. So private void disco ball music, we can go ahead and create that method. And just like before, we do want to play our random sound. So we'll go into our sound collection SO dot disco ball music. That's great so far. But the tricky part is we want to make sure our fight music starts basically when our disco ball music stops. Now, the way that I've set that up is with a float that we can go in and just check the sound length of our specific disco ball music audio clip length. Now, if your disco ball music length that you've chosen is a little bit long or short or something along those lines, you might have to modify it programmatically through code. So I'm going to show you one of what is probably an infinite amount of approaches just to make sure that we're going in and deciding a specific float length for how long we want our disco ball music to play. So, that being said, let's go ahead and create that float called sound length, and I'm going to make that equal to soundcollections.sco.discoballmusic, and then we know there's only ever going to be one, so I'll go into the 0 index of that, .clip.length. And for now, I'm going to show you, I think, a little bit fancier way to do this later on, but for now, let's just keep it simple and let's call it a little delayed invoke method. So even though I don't like string references, for now, we'll just go ahead and call fight music on a delay. And the delay is specifically going to be that sound length. So for now, once we fire disco ball music, basically once we hit a disco ball with our bullet, it'll go ahead and play that sound. As soon as it's finished, we'll go back in and play the fight music sound, which will go through everything up top, and everything should be working as intended. So last but not least, let's scroll up and make sure we're subscribing that function to something. So disco ball manager got on disco ball hit. That probably isn't set to public, so disco ball manager. Scroll up, find our event. Yep, set to private. Let's go ahead and change that event to public, head back into our audio manager, and now we can go ahead and subscribe to that event. So plus equals disco ball music. Let's make sure we unsubscribe to it as well with a minus sign. And then for now, I'm just going to go ahead and create a start method, and we'll just fire that fight music right on start. Very nice. Let's go see how that sounds back in Unity. Let's go ahead and rig up a few things first. we need to drag these serialized fields in. So assets, audio. Let's click our audio manager and then we can just drag these mixer groups in directly. So music into music, SFX into SFX, great. And then back in our audio folder, we need to create a couple more sound scriptable objects. However, this time we're going to create them as music. So sound SO, let's create our fight music. We'll change the audio type to music. We'll change the clip to fight music. We do want this one to loop. And mine is pretty loud, so I'm going to turn my volume down, pretty significantly. I think that's fine for now. I'll just duplicate that and rename this one the disco ball music. And then all we need to do is make sure that it doesn't loop. However, I don't actually think it would matter because of the way we wrote our code. And then we'll change our clip to disco party. So I'm actually just going to go ahead and rename this to disco party as well. And I believe the last thing we need to do is just assign them in our sounds collection scriptable object. So fight music and disco ball, they each only have one. We can go ahead and assign fight music to fight music and disco ball music to disco party. Ah, what a shame. Let's go ahead and clean that up. So disco party, I'll just make sure I rename that briefly. So in our sounds collection scriptable object, I'll click this, click F2, and then just call it disco party with no space. And let's try that out back in Unity. Now, while this is compiling, I think we're going to have to assign this once again. Go ahead and click that, disco party. All right, let's hit play and see how we did. All right, we've got our fight music, groove it. Let's go ahead and try hitting the disco ball. Uh-oh. All right, we definitely messed something up. However, we've got our event of our disco ball rigged up correctly. Let's see if our fight music kicks back in. All right, good, we're halfway there. However, when I hit any other sound effect, like a jump, for example. Okay. So I think we have something set up not quite correctly. Let's go ahead and do some debugging together. So in our audio manager, let's go ahead and open that up. It seems like it's going to be somewhere in here that we're not actually changing the mixer type correctly. So let's see. Okay. So right here in play sound, decently big typo. It looks like I actually wasn't doing a comparison equals. I was actually doing one. So I was trying to do some sort of assignment. I'm surprised that didn't actually give us an error, to be honest. Let's go see if that was the issue. All right, let's hit play and try that one more time. Great, I've got my fight music. I'm going to go ahead and try to fire a couple bullets. Okay, that's nice. We're in business. Let's go ahead and try the disco ball one more time. Plays the disco sound for a few seconds. Now, a little bit of an issue. I've got my disco party float set to, I think, 5 seconds at the moment, but the disco ball music actually lasts a little bit longer. Now, just to kind of give you an example, we can come over here and edit in play mode, and then we can actually modify these mixer groups directly. So if I want all of my music to be a little bit more quiet, which is probably a good idea, I can go ahead and slide that down. If you wanted to do the same for the SFX mixer group entirely, you could do that. And that can be really powerful. Now, it's probably not the best way to go about it, but I'm going to go into my disco ball manager, and then in my disco ball party time, I'm just going to hard code it to specifically 7 seconds, which I know is about the length of that specific audio clip. You could take some additional time going into your audio clip, adjusting the disco ball party time float to be equal to that directly. We already learned how to do that. But for now, I'm just going to go ahead and hard program it in so we can go ahead and move on to more fun learning points to wrap up our course. All right, well done on this lecture. When you're ready to move forward, I'll see you on the next one. Lecture, let's take some time to clean up our audio manager class, as well as implement our own utilities class so we can access from other classes to make sure that we can keep our code nice and clean. Let's open back up our audio manager class and get things a little bit more organized. Because this is a relatively big class and we'll be adding more to it with our other sound effects, let's go ahead and organize things with regions. So the way that we do that is we type region, and I don't think I have any sort of autocomplete, so we need to type end region as well. And then we can actually name these regions accordingly. So I'm going to name the first one our Unity methods. And then I'm just going to drag in all of our Unity methods. So start, on enable, and on disable. I'm just going to go ahead and shift those up to be in between that region. Once that's formatted correctly as such, we can go ahead and just collapse those regions entirely. I'm going to create another one that I'll call sound methods that we can put in all of this custom sound logic that we created. So let's see, region and end region. And then let's go ahead and drag in our play random sound, sound to play, as well as our play sound. Let's go ahead and drag all those up, make sure that is inside the end region, and we'll format that accordingly as well. While I was chatting with you, I got a little bit distracted. I don't actually want to indent these in, so I'm just going to go ahead and shift those back, close my Unity methods, and then we'll go ahead and call this one our sound methods. And we can go ahead and close that one as well. Let's create two more regions for both our music methods and our sound effects methods. So region, I'll call this one SFX. We'll close that region. And then I'm going to drag in my gun shoot, jump, death, and that's it, just those three. So I'll go ahead and shift those in, collapse that, and then let's create one more for music. So region, I'll call it music, and then end that region and do the same. Let's go ahead and shift these up just a tad. Ah, nice and clean. Let's go ahead and open back up our sound methods. I just want to refactor a few things there, but nothing too complicated. And all I'm going to do is let IntelliSense take the wheel. So I'm going to go ahead and reorganize my random pitch. So this if statement here, you can go ahead and click the little light bulb, or I prefer just to hit Control period, I think is the hotkey. Yep. And then we can scroll down here to extract method. With IntelliSense taking the wheel, I'm just going to go ahead and rename this method with F2, and I'm just going to call it randomize pitch. Let's go ahead and do the same for this switch statement. So I'll go ahead and highlight that entire switch statement. I'm going to hit Control period. I'll extract the method, and then I'm going to rename this new method. Once again, highlight that, press F2, and I'm just going to call this one determine audio mixer group. Make sure I don't have a typo in there, even though it's not all that important. And we're set to go. We'll format that with a little bit of a space. And yeah, I think that looks much better already. And I think I only want one more. So somewhere down here, I think in play sound, I'm just going to go ahead and extract this one as well. This one seems like it could be its own method. So I'm going to control period on this whole if statement. So control period, extract method once again. And we'll rename this method to determine music. Nice, we'll give it a nice clean once over, and I think that looks pretty good. We've got our play random sound pretty clean, sound to play looks pretty clean, and yeah, I think we're set to go there. And the next part is extra fancy, so I'll go ahead and close these regions here, and I'm going to go ahead and open back up my music region so I can access this disco ball music method. Now, if you know me by now, I definitely don't like these string references, so I'm going to create this in a way that we have our own public utilities class that we can access from other classes and clean things like this up. So let's go back into Unity and make sure it's compiled correctly. Let's head into our scripts folder, miscellaneous folder, and I'm going to right-click, create a new C# script, and I'm just going to call this utils with an S at the end for utilities. And let's go ahead and open that up. So in this case of our utilities class, we want to make sure that we're not actually inheriting from mono behavior. We're just going to use this as a base C# class. The only thing we want to change is we want to change this to a public static class to make sure that we're not instantiating it in our scene. We just want to be able to access a bunch of methods from other classes as needed to implement some custom logic. And as a reminder, when creating a static class, we just want to make sure that all of our methods inside are static as well. We're going to create a public static void, and I'm going to call it run after delay. Now, this is set up in a really cool way where we can actually take in a specific mono behavior that we can just call mono behavior, as well as a float for the delay that we'd like to wait, as well as an action, which is the same keyword action that we should be familiar with. Except we're going to name our action a task that we'd like to complete. And inside this run after delay method, we can start a coroutine passing through these values to make sure that we're running a method after a specific delay. So let's also create a private static IE enumerator directly in our utilities class, calling it private static IE enumerator, run after delay routine. And this is also going to take in a float. We'll call it delay, as well as that same action. Inside here, we just want to do the same thing we're familiar with, and we want to yield return, wait 4 seconds, passing through our delay. Well, let's not forget the new keyword. After that wait time, we can just invoke that action. So task.invoke, and we can run whatever method that we're passing through after that specific wait time. So in our run after delay, we want to go into our mono behavior and start a coroutine. What coroutine do we want to start? Well, we want to go into our run after delay routine, and we want to pass through our delay and our task action. And with that, because we're extra fancy programmers, we replace one line of logic with looks like it to be about 15 lines of logic in our new class. But how cool is this? Now we can go directly into our disco ball music and access that utilities class logic directly. So utils.runAfterDelay. And then we want to pass through this mono behavior, the sound length float that we declared above, and our fight music method that we'd like to play after that specific delay. And that was a bit of overhead, but you can keep in mind we can now use this run after delay utilities method in our code wherever we'd like. As well as if we want to replace fight music, we're now no longer using string references. Nice and clean. Let's head back into Unity and make sure everything is working as intended before we move on. And because this utilities class is not a mono behavior, we don't have to worry about setting anything up in our hierarchy or our scene. We can simply access that directly. So let's test to see if everything's working. I've got my bullet. I've got my disco ball. Great. And let's see if it actually works. That was a nice long 7 seconds while I was waiting. But it looks like everything is working as intended. All right, well done on this lecture. When you're ready to move forward, I'll see you on the next one.